Hello. In this video, we will learn how to use Python to build a machine learning model that recognizes handwritten numbers. In order to understand how we build this machine learning model, we need to understand the different steps we are going through. This program could be your first step to understand image recognition using machine learning. In machine learning, we don't build models by putting custom rules to perform a task. Instead, we build a model by feeding a dataset, which is a large number of records that are related to the main task. We feed the dataset to the machine learning package, which is Keras in our case. We let Keras learn the rules from the dataset records. We only control the learning process by tuning some parameters. However, the dataset needs to go through a pre-processing step usually. We also design the model based on the task. For instance, in text-related tasks, we design it in a different hierarchy. But here, we follow a certain hierarchy that will be explained later. Then the training process begins, and finally, we evaluate the model. We will be using Jupyter Notebook, which is a popular tool that uses a web application to write code in a notebook, along with that code output. That could be not only a text. The output could be images. Also, custom text parts that explain the code could be added to that notebook, and the notebook could be saved and extracted or retrieved later. Now, the machine learning that we will be using is Keras, which is a popular deep learning package that comes in Google TensorFlow platform. As mentioned previously, in order to train a model, a dataset is needed. MNIST is a popular handwritten numbers dataset. It contains 60K images for training and 10K images for testing. Each image is a 28 by 28 pixels image. Every pixel is represented as a number between 0 and 255, which is a grayscale value. In other words, 0 means a white pixel and 255 means a black pixel. And anything in between could be a grayscale value. So it could be something between white and black. This is important because machine learning models understand numbers. So we need to feed it with numbers, not images. So in other words, we need to transform the images into numbers. As you can see in the right, a random sample is shown. And we can see the different shapes of every number that are used to train the model. Think how this sample is a small portion of the 60K images, and think how efficient the model will be after we train it effectively. One last thing to be mentioned before we start coding is explaining how the model learns. Remember that different model hierarchies are available based on the type of the task. Here, the best hierarchy that can be used is the CNN network, which stands for convolutional neural networks. So we'll be following parts of an example available in Keras website that could be accessed through this URL. The figure here explains how CNNs extract convolutions of the dataset image and process it through filtering and pooling phases until the model builds rules based on the output. Now let's open our notebook and do some coding and understand how we build the model. At the beginning, we need to import some essential Python modules for this task, like NumPy, that provides helpful array functions, and of course Keras, and Matplot to have some visualizations, and image from Pillow to test one custom image. Then we need to define some constants to be used, like the number of classes, which is the one-digit numbers count, because every image that will be used in training and testing is an image of a number between 0 and 9. We need also to define a shape for every image, which is 28 by 28 by 1. Now the dataset files can be downloaded directly by you and processed in order to extract the needed values. However, Keras has some functions that can do this for some popular datasets, like our dataset, MNIST. So this function fills our variables as the following. So load data returns 4 values, which will be filled in xtrain, ytrain, xtest, ytest. Xtrain will hold the training arrays, which are, in other words, images transformed into 60,000 images transformed into 60,000 arrays, and every array is a 28 by 28 array, right? Now, also, the model needs to understand what's the actual value of that image, or what's the represented number in that image. So we need a variable to hold also 60K arrays, where each array represents the value for every record in the xtrain variable. However, here, the number is not represented by a single value, like a value between 0 and 9. It is for every record in our dataset, the label is represented as an array of size 10. And we will see later how, like, one sample of this ytrain labels array will look like. The same thing applies here. We mentioned previously that we have 10K images for testing that will be held out and be used after we complete training in order to evaluate and test our model. That will depend on these. So we also expect xtest variable to hold 10K arrays. Every array, again, is a 28 by 28 array. And the same thing for ytest. We hold 10K arrays. Every array is a single one-dimensional array of 10 cells. And again, I will show you how this and this will look like. And also we will understand this. Let's just understand the extra steps we are following here. So since every the value on every pixel, in order to guarantee it's a value between 0, since it's a value between 0 and 255, as mentioned previously, and we explained that this is a grayscale value. Now, it's better to feed it to the model as a value between 0 and 1. So we take every number here and divide it using this function. We divide it by 255. This way we guarantee that every value that represents every pixel in the images, in the dataset images, is the number between 0 and 1. The same thing also for the testing records. Now, also, we need to convert the values in the Y-train and the Y-test arrays, the inner values inside the arrays, to binary numbers to represent or to tell the model or tell the model know which number is represented by this record. So let's add some cell here and write some code that will, and we print some values out of the data set in order to understand this better. Okay, first let's talk about X-train, which is the training data set. So let's go and print, just to make sure that we are understanding what's X-training. Let's see how many records we have here. So as you can see, we have 60,000 records. Now, every record, as mentioned, is a 28 by 28 array. So let's say, okay, I want to take the first record in X-training, so X-training sub-0, and I need to see the shape of this array. So as you can see, it is 28 by 28 array. Okay, the same applies to X-test. Okay, now, as I mentioned, Y-training and Y-testing is a different thing. So let's print the shape of the first value or the first array in the Y-training. So the shape is as an array of 10 cells. So I want, in fact, to print the array itself. So if I do the following, Y-test tells me that the first testing image is let's do the counting here, 0, 1, 2, 3, 4, 5, 6, 7. So since this labeled with 1, this means that Y-test, the first image in my testing dataset is the number 7. How about the training dataset? Zero, 1, 2, 3, 4, 5. So my first image in my training dataset is an image of number 5. This way we tell the model what is the correct label or the correct class of every image in order to use it to build a rule based on that. So let's see the actual images. Like right now here we got the images converted to numbers, but let's just reflect the process and print out these images to see how the images will look like. So here I have a for loop that will iterate for 9 times. Every time I am calling the rand int number to extract randomly one image from X-training and print it out on the in the output. So let's run this code and see 9 images picked randomly from the MNIST dataset. Cool. If we run this again, we will again pick 9 random images that will be transformed from numbers to images using the image library and also the matplotlib library in Python. Again, we are picking random numbers and we see how the numbers are transformed. We have 28 by 28 pixels. Every pixel here, for example, this pixel here is a black pixel. Now, for example, in the array, if we just take the value of this pixel value will be 0 because it is white, and so on. This way, our model understands and reads and processes the images and the labels of the images. One last step before building the model is to make sure that the model have the correct shape. So we call these NumPy functions. And as we mentioned previously, we need to build a certain hierarchy and make a certain design for this neural network, deep learning neural network. We build a convolutional neural network that consists of 2 layers. The different numbers here and the different activations are the previously mentioned parameters that we use in order to tune the model in order to give us the best performance. So if we run this model summary also gives us a summary for our model and the number of parameters that will be used in order to train the model. Now let's go to the actual process of training the model. The batch size is also one of the parameters. It's the number of the small batch that will contain 128 images that will be fed to the model during training every time. And the number of epochs, which is 15 here, is the number of times that our model will iterate through the data set. So this will be happening 15 times. Again, these also are different parameters that are chosen in order to give the best performance for the model. And finally, this function model.fit will start the training process. We pass our training dataset and including xtrain and the different labels for every image, the batch size, the epochs, and here we devote 10% of the training dataset for validation. So based on that, 10% of the dataset will be used by the model in order to validate itself and to enhance the performance. So let's start the training process, which will take some time. Here, the training took a few minutes and it's about to finish. Now we are in the final epoch. And you can see from the output that we are getting good accuracy, like 98% in the last epoch. So here we got the training completed. So we move to the next step, and we evaluate the model on a data set that has not been seen by the model itself. So remember, previously in the previous steps, we didn't use X-test before. I mean, in other words, the X-test or the Y-test variables were not passed to the model itself. They were extracted here and prepared to be used, but they were not used inside the model. So now it's the time to evaluate the model by passing these and finding what's the testing accuracy. After running this code, we see a really good testing accuracy of 99% and a good loss value. So in order to understand this better and see how the model works and how we evaluate the model, let's do a demo on providing an actual image to this model. So here I will be using autodraw.com, and I will be just preparing one image which is similar to the images we saw here. So let's say that we want a black background, and I'll be just throwing some number, like let's say number 3, and I will be downloading this image and put it in the folder where I perform my work. So I save this image as image.png in the same folder that contains this code. And since it is a PNG image, I will change the extension here. And let's just, before running this code and start parsing this image, let's just understand what's happening here. So I'm depending on the Python pillow image library, which was retrieved here, in order to open an image from the same folder, which is image.png. And I define a size for this image, which is 28 by 28. I perform resizing for this image to meet my standard size for the image. And also I convert it to a grayscale image. Well, so this guarantees that if there is anything other than gray or black or white to be converted to the appropriate color. And finally, I save it as result.png after resizing and I'm doing the conversion. Then I take the image again and I convert it to array. So here we convert that image to a 28 by 28 array called A. Then I prepare another prediction array of zeros, as we are calling this numby function called zeros, of size 28 by 28. And I start reading every pixel value through these two for loops that will iterate by the 28 x dimensions and the y dimension of 28 cells. So I will be reading every cell through this loop, x and y, and divided by 255. And remember, we already explained why previously, why we are dividing by 255. Then I'm saving this value in my xPredict variable that I defined here. So this variable will be used here as a variable for prediction. So in my model, which was defined here previously, I'm calling the function predict, and I'm passing the new image array, which is xPredict, and I will expect an output. The output will be something that will look like this. The output will represent a probability value based on the model prediction for every digit. So, for example, if the model predicts that the image is, for example, 9, this cell in the output will be the cell with the highest value, because it is a probability value between 0 and 1. And we will see the output of this. And also in my output, I'm printing the index of the cell in the array that contains the highest probability. So let's run this code and see the output. I'll go directly to the predicted value. The predicted value is 3. Remember, we draw 3 and we got 3. But why 3 is the highest based on this function, NumPy function, is the highest value that was found. I'm sorry, number 3 is the index of the cell that contains the highest value on this prediction output array. If we examine the different values here for this cell and this one, I see that this one is the lowest. In other words, if we transform it into a probability value, it is 98%. So the model predicted that it predicts that it's 90%, it is this value. So what's the index of this value in the array? So we have 0, 1, 2, 3. So this is the reason of printing 3 and predicting 3. And this is how we predicted number 3. I hope you enjoyed this video, and thank you.